Removable and non-removable discontinuity. Take a look at the limit I gave you. We have limit as x approaches to 2, x squared minus 5x plus 6 over x squared plus 3x minus 10. First of all, I factor the top and bottom, and as you can see, there is a common factor, x plus 2, x minus 2. So x minus 2, the top and bottom, x minus 2 can be cancelled, right? Since x is approaches to 2, if you do not get rid of the x minus 2, we will have a 0 in the denominator. Let me repeat this one more time. Look at the denominator. We have an x minus 2. And then the limit, I let x approaches to 2. If you don't get rid of x minus 2, then we cannot evaluate anything, because when x is equals to 2, we have a 0 in the denominator, right? So it looks like x minus 2, that factor, is our biggest enemy. But after we go through the algebra, we are able to get rid of the x minus 2. So looks like the problem is solved. So after the cancellation, can you plug in x equals to 2? The answer is absolutely yes. You plug in x equals to 2, then you what do we have? Then we have a 2 minus 3 divided by 2 plus 5, right? Then that is equals to negative 1 over 7. So this is the answer to the limit. When x is equals to 2, y is equals to negative 1 over 7, which is a point on the graph. Now, take a look at the factor form. Do we agree that if we just take a look at the factor form without looking at the cancellation, x equals to 2 and x equals to negative 5, they are both the vertical asymptote, right? If you do not consider the cancellation, x equals to 2, x equals to negative 5, they are both vertical asymptotes. So that means the graph has two vertical asymptotes. But if you graph this using your graphing calculator or you use decimals, that is the graph that you will see on the right hand side. There is only one vertical asymptote at x equals to negative 5. Why? That is what we are trying to do in this video. X equals to negative 5 is from where? Is from here, right? Is from the x plus 5, right? We have a x plus 5 in the denominator. Still remember the stuff you learned back in the domain. X plus 5 in the denominator. That means when x is equals to negative 5, we have a 0. That means x equals to negative 5 is a vertical asymptote. Since x minus 2 is cancelled, then we say when x is equals to 2, we have a removable discontinuity. So x equals to 2 is a removable discontinuity. But x equals to x plus 5 cannot be cancelled. So when x is equals to negative 5, we have a vertical asymptote on the graph, and thus x equals to negative 5 is a non-removable discontinuity. So non-removable discontinuity. When you graph the function, the non-removable is a vertical asymptote. So vertical asymptote. Let's practice a few more. So let's do the next one. The next one, I will just do limit as x approaches to 3. How about x to the third minus 27 divided by x minus 3? How do you factor the top? The top is called factor the cube. Still remember this. You have a to the third minus b to the third. What is that equal to? That equals to a minus b, and then times a squared plus ab plus b squared, right? What happens when you have a plus? A to the third plus b to the third. Then you have a plus b times a squared. You change that to a minus ab plus b squared, right? So this one is equals to limit. Or when you do the algebra like this, you always start with limit. So always draw an equal. Start with a limit. Let me repeat this one more time. Draw an equal. Start with a limit. Don't jump straight to the algebra. All right? We draw a long line. So this is a x minus, right? So 27 is 3 to the third power. So this is a x minus 3. And then we have a x squared plus ab. So that will be 3x, and then plus b squared, which is 9, right, divided by x minus 3, and then as you can see, the x minus 3 will be cancelled. So that means x equals to 3 is a removable discontinuity, right? Then it is not, then there is no vertical asymptote on the graph then. Okay, we get rid of the x minus 3, the biggest enemy is gone. Now we are safe to plug in, so we have a 3 squared plus 3 times 3, and then plus 9, so that is equals to 27. That is what the limit equals to. And another conclusion is x equals to 3 is a removable discontinuity. Alright, that is number 2. Let's move on to the next one. The next one, I would like to do this. How about this? Let's do a simple problem. Limit as x approaches to phi, x divided by x plus 4. So in this case, there is no way to get rid of the x plus 4 in the denominator. And I let x goes to phi. What happened? You cannot do any algebra. In fact, there is no need to do any algebra because this one you can just plug in. So that is equals to phi divided by phi plus 4. Phi over 9, that is what the limit equals to. Since x plus 4 cannot be eliminated, then we say x equals to negative 4 is a non-removable discontinuity. And what is that? When you graph the function, what do you expect to see on the graph? That x equals to negative 4 is a vertical asymptote, right? Okay, let's do a tough one. How about this? How about limit as x approaches to 6, 1 divided by x minus 6. This one you cannot just plug in. What is that equal to? In a situation like this, let's take a look at the left limit and the right limit. So what do I mean by left and right? Draw a number line. Where is 6? Put 6 right in the middle, and then we have a left side, and then we have a right side. So what we are trying to pick this time is on the left hand side. I want to pick a number that is extremely close to 6, and then slightly less than 6, but extremely close. On the right hand side, pick another number that is extremely close to 6, but slightly greater than 6. Okay, let's pick a number. So before we pick anything, we have to say x equals to 6. This is the non-removable, right? So non-removable discontinuity, and then x equals to 6 is a vertical asymptote. Okay, let's pick a number on the left side, and then let's pick a number from the right side. Very close, slightly less than 6. How about x equals to 5.99999? That is close and slightly less than 6. On the right side, how about x equals to 6.00001? I use 5 digits on the right hand side of the decimal point. So, and then you do the plug-in, you take that, subtract 6, then what do we have? We have 1 divided by 5.99999, something extremely close. You minus 6, and then you get something extremely small, right? Because the difference is extremely small. So this is negative and extremely small, 0.00001, 4 zeros. And then on the other hand, we have 6.00001 minus 6, right? So that is equals to 1 divided by 0.5 digits. 4 zeros followed by a 1. Okay, what is 1 divided by that equals to? So that is equals to negative this, right? And then this is equals to 1 followed by 100,000. Right? Okay, now, what's your conclusion? before we jump into our conclusion, I want to tell you something that is extremely important, something that you have to think about when you study limit. When you study limit in calculus 1, this is what must go into your mind. Okay, so that is when you have a number, write this down, when you have a number divided by something that is negative and extremely small, something like this, negative 0 point a bunch of 0, followed by a 1. What is that equal to? You will get a result that is negative infinity, negative and extremely large. On the other hand, if you have a number, this is what you have to think about, what you have to process in your mind. Something positive and extremely small, like this. What is the result equals to? The result is positive infinity. Very simple. Let's take a look at this. Let's say 2 divided by 0.01. Is the quotient big or small? The quotient is supposed to be bigger than 2, right? Because 0.01 in fraction is 1 divided by 100. You take the reciprocal, then you have a 200. So when you have 2 divided by something extremely small, you get something extremely big, right? So 2 divided by something extremely small, you get extremely big. This is what I want you to see. So on one side, we have negative infinity. On the other side, we have a positive infinity. Let's use a graph to support this. So the graph, if you graph this function, this is what you expect to see. We have the x-axis and the y-axis, and then 6 is a vertical asymptote, right? So when x is equals to 6, we have a vertical asymptote. X equals to 6, we have a vertical asymptote. As x approaches to 6 from the left, we have this. Y goes all the way down to negative infinity. As x approaches to 6 from the right, y goes all the way up to infinity. So the left limit is negative infinity. The right limit is positive infinity. The left limit and the right limit are not equal. Then we say the limit as x approaches to 6, or whatever the function is, does not exist. All right. So that is the end of this video. If you think my explanation is simple and helpful, give me a like, share, and subscribe, and I will catch you all in the next video. Signing out.